for all elements of A, X also belongs to B. Okay, so this means this. Okay, and this means for all elements of A, X belongs to B, and for all elements, if for all elements X of B, X belongs to A. Okay, if these two conditions are satisfied, these two sets are equal. Well, maybe it's boring for you, but I would like you to uh, get fam be familiar with this kind of language. Okay. Of course, you know all these concepts, but you may not be familiar with this type of, you know, English because it's very formal. Okay. And if A and B are not equal, then we write A is not equal to B. Okay. Now, this is a little bit complicated one. If A is a subset of B and A is not equal to B, we write like this. You notice this part? We write like A is a subset of B, but it's not equal. Okay? So what this means is this. So for every element X of A, X belongs to B. But this does not hold. Okay? So this does not hold. So that means there are some element of B which does not belong to A. Okay, so that means the negation of this statement is there is some element of B such that X does not belong to A. Okay, if this and this are the cases, then we write like this. Okay? We are moving really fast. Any questions? Okay. Okay. Let's move on. Let's explain this example. Okay, let's take this one. Let A equal to the set of X such that X squared is 1. Okay. And let B be the set of two numbers, -1 and +1. Then we have A equal to B. Is that okay? Their expressions are different, but they are specifying the same thing. Okay, next. So we usually assume some universal set. Universal set is a kind of universe. That means it's a set that contains everything we want to consider. Okay. And let's say a universal set is, maybe I should write universal set U. Okay. So U means the universal set. And the subset of U consisting of the elements of U having the property P is denoted by this. Okay. So this is a subset of U. Let's see. This is a subset of U. Okay. So this is a set. This is a set such that consisting of elements of U such that X has some property P. Okay. But since U is the universe, everything we talk about exists within the universe. So we may skip this part. I mean, we can just omit this U part and write like this. But this is just an abbreviation. This is just an abbreviation of this. Okay. Okay, let's move on. Union and intersections. Let A, B, C be sets. There are many sets. The set consisting of those elements, each of which is in at least one of the sets. Wait a minute. Is in at least one of the sets. ABC is called the union of ABC and is written like this. Okay, this is union. And the set consisting of those elements, each of which is in all the sets A, B, C, and so on, is called the intersection of A. So this is intersection. Okay. So you should be able to translate this English in mathematical expressions. Okay. So the set consisting of those elements, each of which is in at least one of these sets. So what does this mean? So let's say this define X as the union of these sets. Then what this definition means is that if X is an element of this large X, then X belongs to A, or X belongs to B, or X belongs to C, or and so on. Okay. So that's what union means. Okay. And similarly, this let's see, intersection. The definition of intersection is this: the set consisting of those elements, each of which is in all the sets A, B, C, and so on. So what this means is that, let's say, let's define this as Y. So if X belongs to Y, then that means X belongs to A and X belongs to B and x belongs to C, and so on. Okay, so this is what intersection means. Okay, and another definition. Uh, the sets A, B, C are said to be disjoint if the intersection of any two distinct sets is empty. That means the intersection between A and B. I think we are missing empty set here. This intersection between A and B is empty. Intersection between B and C is empty. Intersection between C and A is empty. In fact, intersection between any pair of sets is empty. Then they are called disjoint. Sorry, this is a typo. You need to put empty set here. And the union A of A and B and C and so on is said to be a disjoint union if the sets A, B, C and so on are disjoint. This is just the definition of the terminology. Okay, so work out this example and do these exercises. Just to check your understanding of the definitions. If you don't know the definitions, you cannot do anything. So please be familiar with all these definitions. Okay, now we have some lemma. By the way, do you know what lemma is? What does it mean? Anyone know? What's a lemma? Okay, lemma is a kind of theorem. Oh, someone is writing? Okay. A logic. Aha. Yeah, it's a kind of logic. Yes. I mean, it's a theorem. So theorem is